one of the things we know for certain about the brain is that we know very little actually about the brain. And I'm talking about biologists who study brain tissues, experimental psychologists who study behavior, or cognitive neuroscientists who study how the first relates to the second and the second relates to the first, and even evolutionary biologists are trying to figure it out. But one of the things that we do know about evolution and history is that it tells us that our brains appear to be designed to, first of all, solve problems. Secondly, relate to survival, particularly problems related to survival. They are designed to solve problems in an environment that's unstable and typically outdoors. And finally, they are meant to solve problems in an outdoor environment related to survival, and all the while in constant motion. This is typically referred to as the brain's performance envelope. Because we don't fully understand how the brain works, we tend to do some pretty dumb things. Like, for example, have you ever talked on your cell phone while driving? It's literally impossible, according to brain science, to actually multitask when it comes to paying attention. And it's not just us as individuals, but decision makers and policy makers often make decisions. For example, if you want to create an educational environment that was directly opposed to what the brain was good at doing, remember we talked about solving problems and being in motion, we would actually create something like a classroom, probably the least conducive environment to learning. If we want to build a business environment that was directly opposed to what the brain was good at doing, we'd probably design something like, I don't know, like a cubicle. If survival. It really comes down to this whole genetic adaptation that's allowed us to survive as long as we have. I mean, really, it's about passing on our genes to the next generation. There is no bigger rule in biology than evolution through natural selection. And the reality is that the brain is a biological tissue as well, and it too follows the same rules of natural selection. If you are, a caveman days, and you are trying to figure out ways to beat the cruelty of harsh environments, you can become A, either stronger, or B, smarter. And we did the second. It seems almost impossible that such a physically weak species such as ourselves could actually end up taking over the planet by not adding muscles to our skeletons, but by adding neurons to our brains. But that's exactly what we did. One trait that really does separate us from our evolutionary brothers, the gorillas, is the ability to use symbolic reasoning. When we see a five-sided geometric shape, we're not stuck perceiving it as a pentagon. We can just as easily perceive the US military headquarters or the Chrysler minivan symbol, for example. Our brains can behold a symbolic object as real by itself, and yet simultaneously also representing it to be something else. Researcher Judy Delaroche calls this dual representational theory. Stated formally, it describes our ability to attribute characteristics and meanings to things that don't actually possess them. Stated informally, we can make things up that aren't really there. And we are human because we are able to fantasize. Dual representation gives us the ability to combine symbols to derive layers of meaning. For example, it gives us the capacity for language and for writing down that language using those symbols. It also gives us the capacity to reason mathematically and understand the capacity for art. Combinations of circles and squares become geometry and painting, and combinations of dots and squiggles become music and poetry. There's an unbroken intellectual line between symbolic reasoning and the ability to create culture, and no other creature on this earth is capable of doing it. Think about how we use analogies like the ABCs of motor proficiency, describing agility, balance, and coordination. We symbolize these ABC moniker to represent something that's very important in terms of motor development. So let's think about this contribution of symbolic reasoning in the context of evolution. And it not only helped our species survive, but it helped us thrive. I mean, let's look back millions of years ago when we were, our use of tools, which is really the premise by which symbolism has captured our attention from an from an anthropology perspective. The use of tools early on, millions of years ago, by our ancestors was about smashing them together and making things like weapons. And eventually, perhaps maybe these hand axes started to evolve, and we started to use them to chisel and to
Created using Powtoon.